wireless service provider. When I say ISP in Africa, mostly providers are WISPs in Africa, wireless internet provider. Because there's not that much good infrastructure there. No fiber cables, no network that much. So wireless is the main technology, is the toughest. Point-to-point, point-to-multipoint. And most of the providers are just wireless providers. So this is a company, this is the wireless provider with 5 POP sites, and this is their core. So they would have like point-to-point to each of these POP sites. Because when you want to expand your network to another POP site, you need to set up a point-to-point network. I've seen some company for such a scenario using point-to-multipoint networks. It means they put maybe sector antennas at here and supporting their POPs with CPEs. Which can be wrong, depends on the number of clients, the available bandwidth you provide, and location of these POP sites. Because point-to-multipoint cannot carry the same amount of bandwidth as point-to-point devices. So what we prefer, we normally prefer to run a point-to-point link and then set up sectors for distribution. It means you use both scenarios, point-to-point, just to carry your throughput, just to transfer your throughput to the second location, and then you may have lots of sector antennas or sector base stations for distribution to end users. Then you may have some CPE sites for your clients. This is the same scenario in the real map. This is like 4 kilometers difference. This is like 3. This is the closest one, which was like 2 kilometers. So with point-to-point links, you can just transfer your bandwidth to somewhere else and then distribute locally from that POP site. So as you can see, this coverage area shows that this POP site can cover only clients in this area. If you make a heat map, something like this is what we call it heat map. If you make the heat map, then you can find out which house or which region or which street you can support. It's already covered. This is another scenario with 4 main POP sites. This is 1, this is 2, this is 3, this is 4. Another country, but still again in Africa. But in this scenario, what we are using one of the POP sites as the relay, because there was no line of sight between the main point, which we call it NOC or Network Operation Center. There was no line of sight between these two, so what we needed is just making this one as the relay. This is still possible, but you need to be careful, because if you lose this link, if this link goes down, you lose connectivity both here and also in the remote sites. So this link is kind of important link for you. To compare with this one, this link only supports US Embassy, for example. There is no points behind US Embassy. It means if this link comes down, only this point will be disconnected. But if this one comes down, then you have 1, 2, 3, 4 sites down. Then, in this type of scenario, what we do, you still can set up 2 point-to-point links, totally separated, and we call it failover. Means the second one is the backup of the first one. You always work with the first one. As soon as the first one comes down, the second one automatically comes up. So you can have full redundant connectivity. Because this link is so important, if the link comes down, you may lose a lot of clients in 4 or 5 points. Then you may have 2 point-to-point links exactly at the same direction. Now depends on your scenario. You can use them as failover, means the second one is always as backup. And it comes up only if the first one goes down. At the same time, you can use even both. This is what we call it load balancing. It means, for example, one of the link has 10 megabit bandwidth, the other also has 10 megabit bandwidth. It means between these 2 points, if both of the point-to-points are already active, you may have 20 megs. But if one of them comes down, still the other one is failover. Means failover and load balancing also possible to use both of them at the same time.
This is the same scenario, but different type of map. This is a still heat map. It shows the coverage of each. But this network is something we call it mesh network. Mesh, you may have full mesh network or partially mesh. This is partial mesh. Means not all connected together, but there's a connectivity between. For example, if I want to make a full mesh, then I need to connect this point to here, this point to here. I need to make a full mesh. So each side would have backup link as well. For example, if I make another link from here to here, it means US Embassy would have two links, one from this side, one from this side. If this one goes down, the other one comes up. Failover. For sensitive networks, for important areas, you may need to think about the failover, backup link, and balancing. Same scenario in Google Map. This is the head office, or what we call it NOC, the Network Operations Center. Then we distribute to this one. The problem in that scenario was there is no line of sight between here to here. So we needed actually to go there and come back here. That's why I say if you want to run a wireless network, no matter point-to-point or point-to-multipoint, site survey and calculation is really important. Everything starts with calculation. You have to calculate your network as well. This one is our biggest network in the world. This is Nigeria. This is a Wi-Fi distributed network with 2,500 access points. This is the citywide Wi-Fi scenario. We have a NOC and many POP sites, and all you see here, these are access points in point-to-multipoint network, but these are CN pilot. You can be on CN pilot. There is a point-to-multipoint network behind just to distribute to POPs, and from each POP, then there are some CN pilot access points for Wi-Fi distribution. When I say Wi-Fi distribution, means the end user is mobile phone, laptop, devices, user gadgets. So this is like, I think 18 POPs. From the main point, this is the NOC, with the point-to-point link, and between NOC and to each POP, there are 2 point-to-points, because connectivity is so important here. The downtime of this network is, the availability is 95% per year. It means just 5% of the year we might be disconnected. Because we have thought about the backup link everywhere throughout the whole network. This is very sensitive network. This is citywide Wi-Fi, and if just one of the access point goes down, people around that access point cannot get connected. So backup in this scenario was very important. 2,500 access points. Soon this year it becomes 5,000 because we are expanding this network, and this network fully managed from centrally from Cambium CN Pilot Cloud, which called CN Maestro. This is the same scenario and the topology. What it shows with the point-to-point link, for example, you have a very big high pop site. With the point-to-point link, we just bring the bandwidth here, and with 60 gigahertz, I guess we have 160 gigahertz here. Makrotik is the only manufacturer that has made 60 gigahertz. You know, 60 gigahertz is very high frequency. That's why the bandwidth is very high. So Makrotik 60 gigahertz point-to-point device can give you 2 gigabit traffic. Real throughput. Real 2 gigabit throughput. Two models, one of them only in 200 meters, means designed for building to building. For example, if you want to carry 2 gigabit from one building to another, you can just use this one. And it's so cheap, it's like 200-300. It's very cheap. The other version is the one for 1.5 kilometers, 1.5 kilometers, 2 gigabit. But you know that because frequency is very high, it's very line of sight, means alignment might be an issue. And also you may not be able to use 60 gigahertz in all environment, because dust, cloud, rainfall, snow, environmental changes affect this link too much because frequency is very high. But with 60 gigahertz point-to-point, we just distribute to different buildings and also some city poles, light poles or street poles. Then we have a CN pilot access point just to distribute. Point to multi-point, behind Wi-Fi devices, just to distribute between POP sites, and CN pilot devices just for distribution to last mile, mobile phones, laptops, and tablets. This scenario is fully off-grid with WITEC solar switch. I mean, all of these 2,500 access points are powered up with solar version. There is no city power because there's a power problem in Nigeria. City power is not available more than a couple of hours a day, maybe 8 hours or 10 hours a day. That's why we needed the solar stuff. The whole network has been powered up by WITEC solar version. And this is the topology, because what you can see here is just the backhauling distribution, and this is still backhauling distribution to different points. These are our POP sites, this is the main node. But I just revealed one of the POP sites. Then we may have 2 point-to-point. These are street lights. And each street light, we have, let me show you, this is it. You see, each box powered by 2 point-to-point links, one incoming, one outgoing, and this is an access point for distribution. And all powered by solar panel. As you can see, street poles, all of them have solar panel. So even if you have a camera, you still can power up that camera with WITEC switch because it's fully solar. So per each pole, we just need one of these boxes and one panel. This panel can be a bit big, depends on your calculation. Depends how much sun, if your environment is really sunny or if your environment is mostly cloudy. Then it affects your calculation, it affects the size of the panel and also the number of batteries. Depends on your scenario. Also depends on your consumption, how many access points you have. If the consumption is more, then you need to add more batteries. This is all about the calculations. That's why I recommend you, before buying any PoE switch, just do the calculation. Or let us do the calculation for you. So this is our biggest scenario. This is our biggest project. And inside the box, this is what we have inside the box. 2 batteries, 1 WITEC switch, 1 MITSCo router. Not this one. This is just for illustration. The one we have is the small Hex S. The one I showed you, the black small one, is Hex S. Enough for POP sites. More than enough. This is another Wi-Fi project in another country with 15 POP sites and a partially mesh point-to-multipoint network, and we can fully cover the whole area. The reason that we have overlapping here is because this area is very dense area. It's really populated. Lot of people living around this area, so we needed more access points. Some access point may have overlapping, may cover each other, but if you have a full channel management, there will be no problem. Because coverage overlapping is not a bad stuff if you do channel management, if you manage your channels as well, if you separate your channels, coverage overlapping is still good. But if 2 access points are in the same channel, then overlapping may cause a big problem for you. This is a project in Nigeria, in China. Citywide Wi-Fi project, both for the end users and for the buildings. Means there is a fiber to each building, then we distribute with Ethernet cables. And beside this building distribution, there is a city-wide Wi-Fi in public areas like airport or a big national park or different populated areas, metro stations, public stations. You still can have both of these networks beside, and you also can manage them all centrally from your central station, or what we call it NOC. This project is also in Shenzhen, in China, but this is not the wireless project. This is fiber project, FTTX. In this FTTX project, there is a direct fiber line goes to each village from the central office. Fiber cables go to different villages. In each village, then we have local facilities, local routers, local devices, just to distribute inside the village. The idea of this network was to providing internet for more than 500 villages. Up to now, 200 something of them, 250 of them already deployed. This year, we are expanding to other projects. So this is not really a wireless project. This is fully fiber project, FTTX. Some pictures and screenshots from real scenarios. These are really successful case studies because we have researched, we had lots of development before running these projects. As I told you, site survey, monitoring, assessment, analysis, these are very important before deployment. This is that same Nigeria project I told you. What we do here, because Nigerian government has given us access to street poles to set up our boxes, what we give to government is these cameras for visualization. We set up actually this for free to them. It means now Nigerian government is be able to cover the whole city, can see them all from the central control center. They are using our network for these cameras. But the problem is, because camera bandwidth consumption is too much, if you have HD camera, per each camera the consumption is minimum 2 megabit, minimum 2 megabit. So if you have more than 100, 200 cameras, then huge traffic will be in your network. What we do, in some dense areas, we run a second link, second point-to-point link, because 60 gigahertz already can carry 2 gig. If 2 gig is too much throughput actually, but if 2 gig is still not enough for you, you can set up another 6 gigahertz beside. Then you can carry 4 gig. This is the WITEC switch in real scenario. This is in another country, but this is not wireless project. This is only CCTV project, visualization, and covered all up by WITEC switch. This is outdoor deployment. That's why we couldn't put, this is more efficient if you bury your batteries under the ground. Even 1 meter underground is really nice, because it lasts for longer. Your battery can be healthy for longer. Because normally you know that if you take care of your batteries, every 4 or 5 years you need to replace your batteries. They expire and you need to just change. But if you do not well maintain them, if you do not prepare them well, every 2 years you need to change your batteries. That's a big expense for you. So better to keep your batteries in a safe place under the ground, and they can live maybe for 4 or 5 years. This is the real solar versions testing. We were outside and testing the scenario with a couple of access points and security cameras. And as you can see, the power is exactly 12 volts. This is a factory, there's a WITEC factory testing center. They do all the tests and scenarios. So, in case of any questions, as I said, you have got the invitation, the letter, the incoming letter, greeting letter. At the back of that letter, there is the approach. You can write your name, your company name, and contact details. If you needed to talk with me, or if you needed to have a kind of meeting with either of us, myself, LABA engineers, LABA guys, or Network Store guys, just fill out the form. we provide the time slot for you, maybe tomorrow or the day after, then you can just come over. Thank you very much. Now it's time for Mr. Manish from Network Store to demonstrate their case studies, their successful case studies. Thank you very much.